all the regressions part? Yes. So only random forest is pending. Yeah. So let's complete today, and regularization is also pending. So we'll talk about all those things today. Good morning, Archana. Let's do this. May month, and today is 23rd. All right. So now so how much we got accuracy for the same data set, guys? For polynomial, I think 158, something like that. KNN 168. So let's build another algorithms today. What is random forest? I'll give you explanations, not right now. Forest means what, guys? Group of tree. Team, can you hear me now? Team, can you hear me now? Let me know if the voice is breaking. Yeah. So yeah, so what I talk about, so what do we talk about? I mean, last week we completed the decision tree, isn't it? One moment, is that you? 10 m, perfect. Okay, so today we're going to build. All right, so today we see random forest. What is the date? 23rd. Okay, so what is forest, guys? A group of tree. Random forest means group of decision tree. Group of decision tree is called forest. Okay, from the forest, I mean from the tree, when I take the data randomly, yes, when I take the data randomly, that becomes random forest. I hope you understand. And anyway, this is called ensemble learning. So there are a lot of models we're going to learn in the future, like what is mixture model, all right, and ensemble learning, and ensemble techniques. So this is all interview questions. So those things we will understand at classifications, not right now. Okay, because if you think practically, decision tree is a classifications, it's not a regressions. Random forest also a classifications, it's not a regressions. But let me explain directly to build the model using random forest regressors. Okay, using random forest regressors. All right, same data set, we build it. But before that, let me go ahead and we're going to see the documentations of online team. I hope you can hear me. Yes, guys. Random forest regressor documentations. All right, so here we go. See, guys, by the time, please, by the time everybody is understand at least what is parameter, what is hyperparameter. If someone gives you a data set, will you work at least, isn't it? How to clean it and how to all these things. I'm not talking about expert level, isn't it? You just start a beginning, that's good enough. Okay, yeah. So guys, I wanted to show you today morning. I had some free time. I just noticed, I checked some of the openings which I have. I mean, persistence. What is Adani Power Jobs, guys? Anybody heard about this? What is Adani? It's a constructions company. Yeah. So they do requirement machine learning engineers. Did you see this, guys? I mean, you trust me, in earlier days, only software companies are there to take you. But now fashion industry, constructions industry, supply chain industry. Today, I will give one projects. Okay. Let me complete this and I will discuss those things. Okay. Today, I will talk about one project called price prediction. Okay. So when I say price predictions, price is the important factor. It comes under across the domain, isn't it? You take manufacturing, t-shirts, jackets, price predictions, sales price predictions, global stock price predictions. So I'll give you 4 projects, guys, 4 projects regarding to the regressions path. If you complete these 4 projects, then entire regression is complete, guys. That's to be sure. Okay. So now, do you remember in your resume, the project 1 would be what, guys? Risk analysis EDA. You didn't build model over there. Okay. Risk analysis. Now in project 2, you're going to go for price prediction. Let's say Kirtana is update on the resume as stock price predictions. Now you update as like, supply chain management, like some of the wholesale price prediction, something t-shirts and all those things. Any kind of things you're gonna mention this one. So 2 projects, let's talk about. This would be your resume projects, guys. Understand? This would be a resume project. So I'll explain today, but let me go for a random forest and we're gonna understand this. Oops. Cool. Yes, that you need to be added in there. That's the project. Yep. Okay, here we go. So let's go for this one on title and one second. So let's try to restart my kernel. Yes. And okay. So let me try NumPy Pandas, Matplotlib. Let's run it. And then, oops. Okay. Just one more. Okay. And then same data sets. Oh, no. Just one second, guys. I'm sorry. Just one second. (23rd) random forest. Regularization is not completed yet, isn't it? No, regularization is not completed. True. Let's close this. And this is the path. Let me set the path over here. Let me restart the kernel again. Okay, let's see this. NumPy, Pandas, Matplotlib is done. And then this is the quite common, guys, because this is the data set we talk about. Yes. And this should be the independent variable and dependent variable. We know this one, everyone. Okay. Up to this part, we cleared. Cross validations, I'll explain later. So directly, I'm going to build with random forest. Let's click this and just take a help of it. So did you see the random forest regressors means what? An estimator. What exactly mean by an estimator? Let's scroll down and check it out. The number of trees in the forest, isn't it? The number of tree in the forest means I take the decisions from 100 number of tree. This is the by default parameter tune. And the next one, criteria, squared error, absolute error, Poisson. I mean, in In decision tree, what we saw, what package we had? Gini index. Do you see this? Do you, yes, I mean, on Friday I was talk about, yeah, Gini, and then max depth. I will explain later part, all those things, okay? So at this moment, you just need to understand, let's directly build the model from sklearn.ensemble. Let's click it, yes? Can you show the DT data set, please? The same things, buddy. The one which you keep on doing. This is the spider need to be restart. Just one moment, okay? File, save, file, restart. Okay. So in the meantime, I will give you today 4 tasks, okay? Task regressions, let's talk about. Let's close this. And I think I have here. So let's open this one. Project list. Okay. Complete regressions with business case study, okay? So I'll open entire 4 tasks. Just copy this and let's go back to here. So time series do not work at this moment. I didn't explain to you. So once I'll explain, you work on the time series. Okay. And how to compare with all the models with some real-time data. Yes, guys. So once you complete this, you get more confident. I know that. Just one moment. I'll explain one by one. See, did you see comparison of all regressions models? Yes. So, okay. Okay, I connect from my phone. So that's why I'm getting a little bit slow. Just one moment. Okay, but that's okay. That is, spider is up. So no, still it's going on. So what exactly this one? Avocado prices. Okay. So what exactly mean by avocado price? It's a fruit. Okay. So I think, has anybody saw that fruit? So let's go back. I think it's costly. I don't know, but why? I think it's a costly fruit. Yeah. Avocado. Yeah. So this is the fruit price predictions. Understand? So when I talk about price predictions means it is completely, go to the images. It is completely dependent variable is continuous in nature. Okay. So this is the price predictions. In this predictions, I'll give you 4 tasks, guys. Okay. Once you complete, did you see one-stop shop for data science? Yes. This is just an EDA part. Just leave about this one. Linear regressions, KNN, support vector regressors, decision tree, random forest, and time series. In your company, whenever you join, most of the company had sales. They're working only for revenue, business revenue, isn't it? They wanted to check what is the quarterly sales, what is the yearly sales, what's the seasonal sales, isn't it? Those productions they need to do. So let me tell you, my dear friends, when you complete this one, mostly you can match this projects to your company projects. Agree? Everybody's clear? So this projects, if you complete whatever except time series, I'm saying do not work on it because I think they use Facebook profit. One algorithms is here. So you don't implement this Facebook's core data science term. So just leave it about the time series and regularizations. No. Linear regressions, ridge regressions, lasso. Okay, you can also start doing this. I'll explain to the linear, lasso, and ridge. All right. And if you complete this, guys, so mostly You can hands-on to the price predictions, guys. Understood? I mean, all learning, whatever we learned so far from last two weeks about the regressions, it will be done in one project. You take 3 days, 4 days, I don't mind. Okay, you complete or not complete, it's up to you. But this is what the real time is all about. I'm just given. Online team, are you understand? Online team, are you understand? So let's see avocado price regressions, gold price regressions, stock price regressions, seasonal sales price regressions. All right. Your manufacturer price regressions, isn't it? Product price regressions. All the projects come under this, guys. Understand? So if you work this, lot of things makes more sense. Now, did you see the aim of this project is to answer for the following four questions? Which reason are the lowest and highest prices of avocado? Yes. So don't you think which reason the lowest and highest sale in my company? You can talk about this. What is the highest reason of avocado productions, isn't it? And now what is the average avocado price in each year? So what would be the average avocado volume in each year? Understood, everyone? So let's see this. These are the attributes we have in the data set. The first two, 13 attributes we have, guys, isn't it? So let's look at this data: average price, total volume, bags, small bags, large bags, all these things. Means you need to little bit explode this data set because it's not a important, I mean, not a toughest one, which you require anybody's help. All right. Data preparations, explode the data, df.head, missing value checking, understood? Dropping unnecessary columns. Can you do it or not? Do you need anybody's help on this one? Let me tell you, this is your resume project, guys. Okay, this is your resume project. Understand? So I gave you very important. You get a quite good number of calls if you add a time series to it. Okay, if I add a time series to this, then you get a plenty of call. I'll talk about what is Arma, Arima, Serimax, all the models we have. I'm going to explain. Yeah. Now, next one, see, few concept is there because define, you need to write, but still the given the descriptions, why you write this code, right? It's a clearly detailed information is given up. What kind of plot you get it? So now let's see this. Average price of avocado according to the reason, according to the, I already explained Chandrahas. If you join late, okay. So here, if you see this, these are the reasons we have, right? These are the reasons means what? I mean, where you make sales. So sales reason. Then price. What is the average price for according to the reason? This is one insights from the data. Agree, guys, everyone? Yeah. And if you scroll down, what is the highest reason of avocado productions? So do you see any outlier? Box plot represents outliers columns, isn't it? Yes. And remove the outlier values. Remove the outlier values, right? What is the average avocado prices in each and every year? 2015, 2016, 2017, 18. Okay. Very simple one, data modeling. How do you build the model? Changing some column types to category as type. We worked in our sessions, we worked it dot as type, isn't it, guys? So how to change it, the df.info, you know this, df.head, everything's, guys, just continuing explorations. This is one part for it. Now, same data set, avocado price data set, whatever explained right now. Okay, this is what the data sets we have. This data set, I worked in 4 methods. 1, 2, 3, isn't it? And comparison all regressions model, because the comparison very important in the sense, if you see this, this is the fruit, these are the columns, and we, as I told, what kind of skew is this? What kind of skew is this? Zero skew. So we get, it's a, the data is a good, yeah. And in this one, if you check this out, organic fruit and dealing with categorical variable. Okay, how to deal with it? This guy is writer functions, but you can act as a label encoder and one hot encoder as well. Understood? Monthly wise distribution of sales, important or not? Yeah. How much the sale happened based on month wise. So this is the graph. Preparing data to ML models and use. Let me tell you, guys. This guy used all the packages at one line. You don't do like this. If you copy and paste it, this becomes a plagiarism, means copy and paste work. So this code, it's not required. We build linear regressions, we run one package and then write a code, then build the model, then go for, see, look at this, linear regressions, decision tree regressor, random forest regressor, support vector regressor, k nearest neighbor regressor, XGB, extreme gradient boost regressors, mean absolute MAE, MSC, and R square, isn't it? So when you work these things, you got some logic, guys. So how exactly it happened? Deep neural network, leave it. Do not work on deep neural network. Online team, are you understand? Abdul, Avilasha, Argha, Chandramouli, Drakshayani, Kaushik, Muhammad, Wasim. TensorFlow, do not run because it won't run. You get error, okay? This part, you can skip it. Deep neural network, you can skip it, drop out. Rest of things you can work. Rest of things and time series. And then finally, how to comparison all the models. If you see this, did you see, guys? XGBoost, MA, MSC, R square. If you check, everything ranges between 0 to 1, isn't it? So which one has the highest R squared? Which model has highest R squared? XGBoost. How do you find out? See this? As I told you, what is the R square range? 0 to 1. The good R square is between 0.6 to 0.9 or 1, you can say that. Agree? Can you do this, guys? This one? Show hidden codes. How to compare these codes and all those things. Agree or not? Yeah. If I explain, it will take 2 to 3 days, guys. So easily you can understand this. It's not required of explanations. Clear? Yes, guys. So I gave 3 files to you, and this would be your resume number, project 2. Jupyter notebook on Spider, sir. It's yours, Sushma. If you want, you can work on Jupyter. If you want, you can work on Spider. All right. That is absolutely you. The main story is you need to understand the logic. Just one moment. Spider got hang up. Just okay. Yeah. Any questions? So let me show you the random forest. Just 1 second. Let's up. Okay. So in the meantime, let's talk about. See, guys, algorithms not completed yet. It's just a classifications will give a lot of topic and a lot of math concepts, and I'll give you a lot of formula. Okay. So today I wanted to talk about another concepts called regularizations technique. Understood? So let's do this. Yeah. Regularization techniques. Okay. So here, just one moment. Spider. Okay. See, if the Spider is not working today, I'll share the code. You can work today. All right, everyone. Yeah. Let's do this part. Today we're going to see another call called as regularizations technique. What is this? Regularizations technique. Yeah. So in regularization technique, what exactly mean by regularize? So ridge regressions. Okay. I'll give you one equations. Can you tell me as well? If you see these equations, guys, if you see these equations, all right, 0.9, this is 0.9 plus 1.2x1 plus 20x2 plus 39x3. So how many independent variable we have? 3 independent variable, isn't it? So which independent variable is highest impact to the dependent variable? X3, isn't it? So X3 variable is highest independent, correlate to the dependent. What about next one? X2. So these are the what? coefficient of independent variable. Agree or not? Yes. Now, what exactly mean by regularizations? So what is meant by overfitting? What is meant by overfitting? When you train the model with more features, and also let me give you, if I give you what is 2 into 3, you said 6. But if I give you one task, what is 999 into 999, what happened? You take a calculator and you can give me answer. Understand or not? The same way, when you train the model, model also understands some of the coefficients up to some level. After that, they don't understand. So let me tell you, when you train the model with high coefficient, when you train the model with high coefficient, okay, so what happened? Overfitting problem happen, guys. Understand? Overfitting problem happens. Clear, team? Yes. Right. So in this case, I need to restart the system. Then okay. I'll share the code random for us. You can practice today. Okay. In the meantime, let's talk about this one. When you train the model with high coefficient, what problem happen? Overfitting happens. So if this scenario, if I apply, okay, CENARIO, if I apply the regularization technique, what technique? Regularization technique. So what are the technique we have? We have 3 type of techniques. One is called lasso regularizations, which is called, also we call lasso regressions. Also we called L1 regularizations or regressions, whatever we called, and ridge regularizations or ridge regressors, and L2, right? And last one is elastic net. Elastic net is what, guys? Combination of lasso and ridge. Okay, combination of lasso and ridge. So let's understand one by one. So what exactly ridge regressions it will do? The formula, look at this. Ridge regressions equal to loss functions plus penalty. What is this? Loss functions plus penalty. What is meant by W? W is the coefficients of each and every value. So this is the formula. You no need to remember this formula, but just to understand, guys, what exactly this one. So if I apply the regularizations, okay, if I apply the ridge regularizations, what happened? The 39 coefficient, the magnitude of x3 has been shrunk down to 5. Understand? So 39 has shrunk down to 5, and 20 has shrunk down to 2, and 1.2 has reduced the coefficient to 0.7. Do you think, I mean, I've been reduced the magnitude of each and every coefficients, isn't it? Online team, I hope you understand what exactly I'm doing. I'm trying to reduce the coefficient of these independent variable from high magnitude to low magnitude to not get overfitting problem. Yes. So what happens if overfitting problem comes, guys? High error and less accuracy, isn't it? Online team, you understand? Yasin, Nischit, Pavan, everyone, guys. Vinod, Uday. Can you hear me, guys? Okay, thanks. Yeah. All right. So this is what happened. So how exactly it happened? How 39 has reduced to 0.7? Because what is loss function? What is loss functions, guys? Difference between actual and predicted. Yes, difference between actual and predicted. Penalty, what is meant by penalty? The sum of each and every coefficient of independent variable. Okay, and we need to consider the alpha equal to 0.1012. So this is math part, we don't need to reductions. That's right. Okay, so this is what exactly called ridge regularizations, guys. Now let me tell you. So this is what ridge regularizations. Yes, we need to implement the loss plus penalty, all those things. I hope you understand. I hope you understand, guys, what is meant by ridge. So let me write down. So the ridge regularizations is reduce the high magnitude to low magnitude to overcome what problems? Overfitting problems, right? This is called ridge regressions. Can we see what is lasso now? Can we see what is lasso, guys? So let's see. In the lasso regressions, so what happened? Check this out. 0.9, 0.9, 1.2 x1, same equations. Anybody tell me what is the difference between lasso equations and ridge? Square has removed over here, isn't it? So in ridge, square was there. Yes. And in ridge, the square is not, lasso square is not there. Correct. So in this case, what happened? Correct, Chandrahas. So here, 39 has removed to 5, reduced to 5, but 20 has reduced to 0. Understand this, 20 has reduced to 0 and 1.2 also reduced to 0. Understand or not? So what happened? If I train the model with 1, 2, 3, 3 attributes, after apply the regularizations, what happened? I train the model with only one attribute. So can I say lasso regulations is also a feature selection techniques? Very few of them understand. Got it, guys? Interesting or not? How exactly lasso is reduced the feature because of loss, functions. And also what is meant by overfitting? Prevent overfitting because I reduce the feature. When I reduce the feature, what happened? The overfitting is gone. We're gonna get a absolute good accuracy, isn't it? So lasso, what is the difference between lasso and ridge now? What is the difference between lasso and ridge? No, lasso, it will reduce the coefficient to 0. Okay, but in ridge to not 0, but almost equivalent to 0, like 0 0.1, 0 0.2, 0 0.3. I hope you understand. So lasso, let me tell you, Washima, you understand? Abhinav, are you there? Just one moment. Yeah. So lasso regressions, regularizations has reduced the coefficient to 0. Understand, guys? But ridge, what exactly ridge will do? It not reduce to 0, but regularize the reduce of coefficients to almost around 0, near to the 0, near to the 0 or closer to the 0, but not 0. Understand, guys? But not 0. I hope you everybody's understand, guys. This is what exactly the technique is all about, lasso and ridge. So now I hope to reduce overfitting, how many techniques we saw? One PCA, another one regularizations. Only 2 techniques we saw. Feature selections, what are the feature selection techniques? Scaling. I'm not talking about feature selections. Selection, featured selection, embedded method, wrapper method, and backward eliminations, and lasso regularizations as well. I hope you understand. Do we get underfitting? No, Ashok. Very good questions. No, we'd never get underfitting. Understand? Yeah. Yes, Ashok. That's correct. Yeah. I just give that example. Okay. I just give you that example, Ashok, so that you guys can understand. Clear? Okay. So this is what lasso and ridge. Let's see. I have some work for you for lasso and ridge as well. If you see this, what is elastic net? Let me talk about what is elastic net. Let's close this. The elastic net is the combination of lasso and ridge. Did you see this both formula? Ridge regression is loss plus penalty square. Yes, the lasso loss plus without square. So this one ridge is not reduced to zero, but it's regularized. It is reduced to zero. What is meant by elastic net? It's a combination of ridge, see, loss plus this square plus this one. So combination of lasso and ridge is called elastic net. Understand, guys? So what exactly elastic will do? It inherit the concepts of multi-collinearity. What is meant by multi-collinearity? Attribute, build the model with relevant attribute. What is lasso features? Good features, feature selections, isn't it? So elastic net inherit the concepts of multi-collinearity from ridge and feature selections concepts from lasso. That's why elastic net is combination of both. But in real time, we're going to use lasso or else ridge. Clear, everyone? I hope you guys understand what is meant by lasso regularizations and ridge regularizations online team. Yes, guys. So in practically, how to see this? Just one moment. Just 1 second. In practically, just go back to this one. Just 1 sec. Okay. How I generate the coefficient, guys? Who will given the coefficient of the data set? By my packages? Yes. We cannot compute the coefficient of the packages, guys. It is created by my OLS starts model. Yeah. Let's do this. Just 1 second. So this is called cars miles per gallon. This is not your resume projects. Understood? This is not your resume projects, guys. So let's go back to the data. And this is what CSV we have. If you go to the notebook, I'm just giving you some examples for this one. So what we do, featureizations, model selections, tuning, linear regressions. So perform EDA, we build linear regressions, ridge regressions, lasso regressions. Understand? So these three regressions we build for the data. So when you see this in the data set, see this pre-processing, you know this polynomial features. What is this? Polynomial regressions, train test split, you know this, linreg, ridge and lasso. When I apply ridge, what the functions we formula? Loss functions plus alpha weight of square. This package is called in the backend. Understand? This formula is called in the backend. So you don't need to remember the formula, guys. All right. Let's close this. Now, if you scroll down, cars, we have miles per gallon, cylindrical, dispersants, HP, and year of origin. All these things attributes we have. So Chevrolet and all the car names we have. Drop car name. All right. So data.head model building. You know this, guys. Already we explained. We saw this. Okay. Simple linear model. I don't want to explain you again. You can build easily for all these models. Now, the coefficient of this attribute is 0.32. Listen to me very carefully. Okay, what exactly the regularization is doing? It reduces the coefficients, right? So at this moment in the data set, the coefficient of each and every variable is 0.32 and HP is minus 0.22, 0.71, 0.01. Clear? How do I got the coefficients? Let's look at this linear regressions fit the model. Intercept. What is meant by intercept? C equal to regressions model dot intercept 0 of format intercept means you get the all the coefficient of all these variables, right? So once we got this, regularize ridge regressions. Ridge will turn down to 0 or not? No, lasso will turn down to 0. But what happened if you apply ridge? What happened, guys? 32 has been reduced to 31. Understand or not? Clear? Now the next part, 32 has reduced to 31 again. 0.22, same. Let's see this. This is the, by apply the ridge, the coefficient of the independent variables are reducing, isn't it? Did you see this case? 0.0192, 0.04. It's reduced or not? This is what ridge. This is what ridge. Now let's talk about lasso. Let's talk about lasso. If you scroll down, see this, what happened? So finally, 0.32 has turned down to 0. Clear or not? Everybody's understand, yes? The next one, my 0.32 as again turned down to 0. How many features we've been eliminated here? 1, 2, 3, and then 4, 5. So I have 1, 2, 3, 4, 5. I trained the model with 1, 2, 3, 4, 5, almost like 8 to 9. But apply lasso, what happened, guys? All the features I reduced, guys. So here we notice many coefficients are turned to 0, indicating drop of those dimensions from the model. Understand or not? So once you build this one, you know the concepts, you know the logic, and you know the, excuse me, which batch, ma'am? Testing? No, this is data science class. No, just wait. I'll done and then the class will start. Okay. No problem. Okay. All right. So once we got this is what happened, guys. All the values has reduced to 0, isn't it? So this is called about the regularizations, guys. Let me tell you, if anybody asks regularizations, explain the way I'm explaining, you will clear the interview. Okay, guys? Understand? So in regularizations, we understand ridge, lasso, elastic net, and I gave you today few things. Till this one, I give it to you today work. Okay, so let's, I think I already assigned to you. You can, this 2 part is pending. Let's copy and just 1 second, guys. Or else I can paste over here only. It's better. It's better. I can paste here. Okay, so there's a lot of work for you guys today. Yeah, there's a lot of work for you because this is your project. This is your lasso and ridge, and I'm going to share with you. See, guys, before that, online team, I hope you understand everyone. Yes, Abdul, Avilasha, Nishu, Chandrahas. So which one is better, ridge or lasso? Pratyush, we cannot say which one is good, but you can implement both. You can implement both at data. Okay, Pratyush, you can implement both on the data set. The next one, I just wanted to show you something, guys. Here, did you see, guys? Let me tell you, you should prepare your LinkedIn profile so nice. Plenty of jobs you can apply from the LinkedIn. Okay, and let's check. There's a good opportunity for freshers. I'm just noticing few informations from freshers today. Persistent Systems, wonderful company. All right. Cognizant, there is a huge opening is going on. Even though for Salesforce, #1 company. All right. So you can apply for Insta Hire. Just go to Google, apply on, when you apply on Hyderabad walk-ins. Did you see this? Hyderabad walk-ins. You can directly apply from there, guys. Just give me a few days. I'll complete the classifications and you can start immediately. Customer engineering, machine learning. Okay, when you open this one, apply on Monster, apply on, these are the websites. Did you see Jubilee, Job, Rapido? I gave you these websites to my, my other batch students, right? So you can apply all the, every day you should apply 200 jobs, guys. How many jobs? 200 by hook or crook. Okay, so this is what, please, you can try. 2 days ago only, mid-level of ML engineer. But see, the saying 5+ experience required with it. Okay, so anyway, we talk about later part those things. All right, guys. Yeah. Okay, see you tomorrow and see you sample resume. I'll give. Sir, there will be 4-5 projects on a resume. No, only 3 to 4 Tejasvi based on your experience. All right. Yeah. Okay. See you tomorrow. Guys, I'm sorry. Tomorrow there is no class. I have some work. We'll meet up on Wednesday. All right. We'll meet up on Wednesday and we will start. Anything missing? Classifications. Yeah. We'll start classifications. Okay. Wednesday. Yeah. No, not required. Hyperparameter is not required on that case. Automatic that. Coefficients, when you decide, it will bring the coefficient automatically. The packages take care of it. Because PC also do, but PC most for unstructured data. So PC normally we don't use it on tabular data. Those things we'll do on unstructured data. Okay. Can I have your WhatsApp number? Syed, just 1 second. Did you join recently? Okay. Yeah. Thanks, guys. See you tomorrow. See you on Wednesday. Okay. Tomorrow, no sessions. Okay.